In section 8.8, we are solving radical equations and inequalities. Step 1 was to isolate the radical if possible. It's not always possible, but we would like to try to make the problem easier for us. So anything that's inside the radical is okay, we're going to leave it alone. Anything that is outside the radical, we want to move to the other side of the equation. This has -3 that is after the radical. We're going to move it to the other side by adding 3 to both sides of the equation. Once we've isolated it, we need to raise both sides to a power in order to cancel out the radical. And to decide what power we're going to use, we look at the root. If this is a third root, then I will use a third power to cancel it out. So I'm going to raise both sides of this equation to the third power. Roots and exponents are inverses of one another if they are the same. So a third root and a third power are inverses, they cancel, and you get 2x plus 1 on the left-hand side. In class, the most common mistake with these is multiplying rather than using an exponent. So you're not multiplying 3 by 3, you're multiplying 3 by itself 3 times. So 3 times 3 times 3 is 27. And now you have a linear equation that we need to solve for x. So subtract 1 and divide. 26 divided by 2 is 13. You always want to plug it back in to check. They're not always going to work. So if I substitute 13 in for x, 2 times 13 is 26, plus 1 is 27. Then we're going to take the third root of 27. The third root of 27 is 3 minus 3 is indeed 0. So x equals 13 is a valid solution for that radical. The second one I'm doing is number 32. We're going to follow the same process. This has 2 numbers that are not in the radical, so I need to move both of those to the other side. We do addition first, addition subtraction, so I'm going to add 7 to both sides of the equation. Those cancel. Now divide by both sides by 2 to cancel the 2 out or to move it to the other side. I have the radical isolated now. I need to raise it to a power to cancel it out. If there is not a root written, if it doesn't have an index, then it automatically is a 2. So I'm going to use 2 for my exponent on both sides. 2 squared is 4. On the right-hand side, a square root and squaring a number are inverses, so those cancel. X minus 7. And then we add 7 to both sides. Once again, make sure you check it. 11 minus 7 is 4. Square root of 4 is 2. 2 times 2 is 4. Minus 7 is -3. And again, it works. I chose this one because it has a polynomial on the left-hand side. It has a binomial. So the radical is already isolated on this one. I don't need to move anything away. It's a second root, so I'm going to use the 2 for my exponent. Square both sides. This is the one, remember, that you cannot distribute the squared through. So you cannot just do x squared and 3 squared. Squaring it means that you're multiplying it by itself 2 times. So I'm multiplying an x plus 3 and an x plus 3 2 times, and we have to distribute. So I get x squared plus 3x plus 3x plus 9, and we can combine like terms. On the right-hand side, second root, second power are inverses, they cancel. We have x plus 5. We have an x to the second now, which is a quadratic. So we want to get those set equal to 0 always. I'm going to move the x and the 5 over to the left-hand side by subtracting them. And now I have it set equal to 0, which is what we want. Your two options now are to factor or to use quadratic formula. Two numbers that multiply to 4 and add to 5 are 1 and 4. So if these are my factors, to solve for x, I need to know what makes each one of those 0. So what could I put in for x to make x plus 1 equal to 0? Would be -1. This one is -4. Now this is where you most often see solutions that don't work. I need to plug both of them back into the original equation. I'm going to rewrite it down here to check to see if they actually are solutions. If I substitute -1 in, so I got 2 equals the square root of 4. Well, the square root of 4 is indeed 2, so -1 is a good solution. Now I also need to check -4, so I'm going to put -4 in for the x's. Is the square root of 1 -1? No, it is not. It is +1. This is not equal. It's not a solution. It means -4 wasn't a solution. Doesn't work. Our only solution is x equals -1. The last one I chose is an inequality. It says extra just because it's not a problem number in your book. All of the good inequalities were assigned in your assignment, so I just chose a different one to do. So we need to make a number line, and we're going to make a number line every time. That's how we're always going to start with these inequalities. It's not an equal, it's an inequality. So the first number that I'm going to make my little dashed line, my first barrier, is whatever makes this radical equal to 0. So the part that's inside the radical, that 2x minus 6, I'm going to set that equal to 0 and solve for x. So add 6 to both sides and divide by 2. X equals 3. So 1, 2, 3, that's my first boundary that I'm going to draw. Remember, I'm trying to divide this number line into sections, into intervals, and then we're going to check each one of those. So to find more boundaries, we need to solve this as we would an equation. So the same way we did the previous few. I need to isolate the radical, so I'm going to move the 3 over, subtract 3 from both sides. And I'm just even going to use an equal sign for now because I'm just finding the barrier. I'm not worried about signs or anything like that right now. 9 minus 3 is 6. To cancel out a second root, we use the second power. So square root, squared, cancel. You get 2x minus 6. And then 6 squared is 36. So we need to add 6 to both sides. And divide by 2. So x equals 21. And we need to obviously revamp my number line because I only went up to 5. So probably should have found my boundaries before I actually did my number line. Okay, so there's the 3 again. And again, we found that from setting the part inside the root, the radicand, equal to 0 and solving for x. And now I'm going to draw my second boundary at 21. So our graph is divided now into three sections. Here's a section, here's a section, and here's a section. And all of the numbers in each section, either they were all work or none of them were work. So we can choose just one number from each of these three sections to put into the original inequality to see if it works or not. It's like when we were graphing them and you pick one point to test for your shading. We're doing the same thing except that it's on a number line instead of a graph. So in this first section I would probably pick 0. If I put 0 in, I get the square root of 2 times 0 minus 6 plus 3 is less than or equal to 9. Well, 2 times 0 is 0 minus 6. Now I get the square root of negative 6. You can't take the square root of negative 6. So that means that you can't have 0 as a solution. So these numbers, if 0 is not a solution, none of these numbers in here are solutions. So I'm going to write no to that whole section. Just because that one didn't work, now nothing in that section works. So now I need to check from 3 to 21. I can pick any number in between 3 and 21 to plug into here. Let's put 5 in. 5 would be a good number. So remember, you can pick anything you want. You can use decimals, you have a calculator, but I'm trying to be strategic. 2 times 5 is 10, minus 6 is 4. So I have the square root of 4 plus 3 is less than or equal to 9. Square root of 4 is 2, plus 3 is 5, less than or equal to 9. That's true. 5 is less than 9. Yes. So because one number in that group worked, now everything between my two boundary lines right there will be solutions. Now my last one, I have to check something over here. Remember, they normally go alternate, but it's not always the case. So even though I know that you'll be annoyed, we still do need to check one number from every one of the sections. Oh geez. I don't know even what we're going to do. Nothing great here. 22, 23, 24, let's check 25. This will show you that you don't always have to have it come out nicely. So 50 minus 6 is 44. So 44, we know it's bigger than 36. Square root of 36 is 6. So this is going to be 6 point something. You can use your calculator. I don't have one with me right this moment. Plus 3 is less than or equal to 9. Well, 6 point something and I add 3, that's not less than 9. It's going to be 9 point something. So that does not work, which means that that whole section is a no. So now we're looking for, yes, what numbers do work? These numbers work. I have to figure out how to write it. Everything between 3 and 21. So x has to be less than or equal to 21, but greater than or equal to 3. All the numbers between 3 and 21 are solutions.